MS Research Australia is now 11 years old. We celebrated our 10th birthday last year, and we were established from the MS societies in each state of the country who provide care and services to people with MS, but also raise funds for research. And they came to the realisation that they couldn't focus enough of their attention on the research side of things. And so MS Australia, which is the peak body, the federation of the state societies, if you like, worked together with the states to set up a totally separate independent research organisation that would dedicate its time and resources to coordinating and funding research in Australia. And so over the last 10 years, we have really been able to vastly increase the amount of funds that are going towards research in Australia. And we have an incredibly robust, rigorous peer review process whereby we select the best research, no matter where it takes place in the country, to fund that research and get the most bang for our buck out of the funds that are hard raised by the community, and make sure that they're funding the strongest research that has the best chance of contributing on the global scale to finding out as much as we can about MS and as much as we can about coping and dealing with MS and treating and preventing it. So our research goals are the prevention of MS, to find better ways to diagnose and treat MS, improve treatments. And when I talk about treatments, I mean both the disease-modifying, immune-modifying drugs that you take to control relapses, but also treatments that help you with the day-to-day living with MS. So the symptom management, the rehabilitation, psychosocial support, and so on. So we mean, when we talk about treatment, we mean both of those things. And ultimately, we'd like to be able to undo the damage that has been done by MS in many people already, and think about ways to repair and regenerate that tissue. Many people think about that repair, undoing the damage, as being the ultimate cure. And I think in one definition of the word, that is the cure. But I think also being able to control the disease to the extent that there are no relapses, there are no lesions on your MRI, there's no damage to the brain, and you feel well and continue to live well, can also be considered in some ways a cure. So the term cure can mean many different things to many different people. But I think what we hope to show you with the research we're going to talk about today is that we're trying to work towards the sense of a cure in many of those different definitions. So as I said, we support Australian research wherever it takes place in the country, so long as it is the best research. We have a really strong process of assessing research applications to make sure that the science is strong, that it's relevant to MS, and that it's actually we can see a clear pathway through to it making an impact for people living with MS. So those are just some of the research organisations that we work with around the country. And I will hopefully have time at the end to touch on a bit about how we're working with the international community to support research as well. I don't think I need to go into too much detail in this room about what is MS, but I just wanted to show, to start by just covering the basics. So we know that MS is an immune-mediated disease, and it's caused by the immune system attacking the nervous system, attacking in particular the myelin, the fatty sheath that insulates the nerves in your brain and spinal cord. Now, without the myelin, the nerve fibres are not able to conduct electrical information as efficiently as they can when they are coated with myelin. So the impact of having the myelin removed from nerves is that the conduction slows or stops, and that means that your brain and spinal cord are not able to send signals to the rest of your body to tell it how to function. And so that's the result of the symptoms. The many and varied different symptoms experienced by people with MS depend very much on where in the brain and spinal cord those attacks are taking place. And that's why we see so many different symptoms in MS. The other thing that can happen to the nerve fibres when all the myelin is removed is that the nerve fibre itself can become very vulnerable to damage. If the myelin is not repaired, then the nerve fibre itself can be damaged and cause permanent loss of function in that nerve, and that's where we see permanent loss of function in the body. So there are many things going on. to do with the myelin and the nerve itself. And that's why MS is a very complex disease to research. So we know that the nervous system is impacted and involved in the disease. We know that the immune system is involved in the disease. So the science going into MS has to cover all of those different fields. And that's why I'm going to be going very rapidly in my talk through a whole range of different areas of science that we talked about over the last couple of days at the conference. Because I want to give you an overview, a sort of bird's eye view of the types of research going on and why we're doing these types of research and what the ultimate goal of that research is. So those are some of the fields there listed. The top 4 are very much in the biological area, looking at the mechanisms, looking at what's happening in the brain and the immune system. And the 5th pillar of our research there, if you like, is the living with MS. It's the day-to-day impact of MS on the body and on your life that we try and tackle with other areas of research, such as allied health and physiotherapy. So, and there are some areas of research that I'm going to very much skim over because my colleagues are going to cover some topics in their talks so I won't need to go into so much detail, and I'll leave that to them. So I'm going to start with talking about some of what we know about why MS happens. And we don't know the exact cause or causes of MS, but we do know some of the things that make it more likely that a person will develop MS. And there was a very big session, in fact 2 sessions really dedicated to this at the conference in the last 2 days, to do with the genetics of MS and also to do with one of the risk factors that has been identified most strongly with MS, and that's ultraviolet light and vitamin D. So we were very fortunate to have Professor Annette Lange de Gold come from the United States, from California, to talk about her research in vitamin D. And we also had Professor Prue Hart, who is our own homegrown expert in the role of ultraviolet light in MS, and that's Professor Prue Hart from WA. And these 2 scientists gave 2 keynote lectures, one after the other, which complemented each other really amazingly. And it was really beautiful to see the conversations that took place after these lectures as well, the science that was discussed and the connections that were made. So over many, many years, the evidence that low vitamin D is a risk factor for MS has been building up. And also that sunshine itself is a risk factor, or lack of sunshine is a risk factor for MS. Now, of course, those 2 are intimately linked, and it's hard to tease them apart. But that's what these researchers are really trying to get to the bottom of. Is we know that people who have had low exposure to sunlight are more at risk of developing MS. We know that people who have low blood levels of vitamin D are more at risk of developing MS. So is the vitamin D the reason for MS, or is the ultraviolet light, which helps to synthesize vitamin D in your skin, is that doing something else in the body as well? So it's not a simple thing of, okay, let's take some vitamin D supplements and then we can reduce the impact of MS. We really need to understand the biology that's going on here. And so Professor Lange Gold has been studying people in California, and in California there's a very wide range of racial diversity, ranging from African Americans, Latin Americans, and Caucasian Americans as well. And she's been looking at those 3 different groups in relation to vitamin D levels and sunshine exposure and MS risk. And one of the really interesting things that has come out of her research is that African Americans, who obviously have very dark pigmentation in the skin, have very low levels of vitamin D. But in actual fact, they're not at any greater risk of bone fractures. We know that vitamin D is involved in bone health. They're not at any greater risk of bone fractures because their kidneys have actually developed ways to resorb calcium much better than white people's kidneys. And so their bone health is actually really good, despite having very low levels of vitamin D. And what she found in African Americans as well is that while sun exposure, low sun exposure is a risk factor for MS, vitamin D deficiency is not a risk factor for MS in African Americans. So that gives us a clue that ultraviolet light has an impact on the immune system, which is separate to the impact that vitamin D has on the immune system. And Prue's work is also, she's been working more in animal models that mimic MS, and she's been looking at the actual biology of how ultraviolet light changes the biology of the immune cells in our bodies. And so together, or not just those two, but all around the world, there are many researchers looking into this issue. And we're beginning to tease apart the different roles that UV and vitamin D play in biology and in multiple sclerosis risk. Now, in Australia, we have a really critical mass, a collection of experts who have really taken great interest and built up expertise in understanding vitamin D and MS. In the white population, we do know that low vitamin D itself is an independent risk factor separate from ultraviolet light. But we don't know, what the studies have not yet been able to show, is actually if taking supplements can prevent the development of MS or change the course of MS after it's developed. And so MS Research Australia has funded a collaboration of researchers from all around the country who are running a clinical trial in people who have had their first episode of symptoms that suggest they may go on to develop MS, and see whether supplementing those people with MS will stop them from having a second episode and therefore a definite diagnosis of MS. And meanwhile, at the same time in Perth, Prue Hart is conducting a study of UVB phototherapy, so light therapy for people who have also had a first episode of symptoms, to see whether that will independently also prevent or delay a second episode and therefore a diagnosis of MS. So these two studies have very similar protocols. They're running in the same way. The only difference is the treatment that the patients are receiving. So we hope that the data from both of these trials will give us some of the answers that we need about, is supplementation of vitamin D going to be useful to prevent MS? If so, what is the right level of vitamin D to be taking, or what is the right blood level of vitamin D that we need to achieve? And so we'll get some really interesting answers out of that. We know that MS is not inherited in the strictest sense of the word, but we do know that MS, if someone in the family has MS, then other family members are at greater risk of developing MS than the general population. So while it's not inherited in that strictest sense of the term, we know that genes play a large role in your risk of developing MS. And so some studies, this is Professor Simon Broadley's work he's from Queensland, and he looked at the risk of MS in families and has shown that sort of the more genetically related you are to a person who has MS, the higher your risk is. But it's not cut and dried. It doesn't mean that you will develop MS if you have a family member with MS, but we know that the risk is higher. So all around the world, scientists, including Australian and New Zealand researchers, have been gathering DNA samples from people with MS, and they pulled them all together. And over the last 4 years, we now have a collection of 110 genetic variations that we know are involved in the risk of MS. They account for about 50% of the inheritability of MS, or the genetic risk of MS. So there's still more information out there about genes that we need to get, but we're really getting closer. The majority of those genes appear to be involved in the immune system rather than the nervous system, so it gives us clues about the cause of the disease. Some of those genes give us clues about how we might treat disease. They're targets that you can design drugs against. And so while it was a huge project and there's still much more work to be done in the genetic area, we're getting some really useful information out of it. So over the course of the conference, some of the researchers were talking about individual genes and how they might predict whether you respond to a treatment or not, how being able to use a sort of panel of genes, a combination of genes, might help to predict whether someone might develop MS, or even what type of course of their disease will take. So there was a huge number of talks. We made them all talk really fast and for a really short period of time because we wanted to get as much of a breadth of information about what was happening with genetics. And so we're not there yet in it being able to predict MS or to say whether you're going to develop an MS from your genes. But I think over the course of the next few years, we'll get some really useful things coming out of this that help clinicians and patients make decisions about treatments based on the genes that they carry. and that's an area called pharmacogenetics. And there's another area called epigenetics, which is looking at how the genes, while they don't change, they are actually controlled differently, how the activity of those genes goes up or down depending on what genetic variations you have, and how that impacts on the immune system. So another area, and this, I have to say, my personal bias, was my favourite part of the conference, was the session about myelin repair. In Melbourne, you have the collection of the most amazing young scientists who are looking at myelin biology and working towards myelin repair. I was absolutely blown away by the quality of those talks, and that most of them here in Melbourne. There's some really excellent research also going on in Tasmania, and there's a huge amount of myelin research going on around the world. And you're going to hear from Jia Lu after me, who is going to talk about her work in myelin repair. But, you know, Melbourne, it's a hotbed of activity. These scientists are looking at trying to repair myelin. And a lot of you will have heard the term stem cell, and you immediately think about stem cell repair as being an implant or a transfusion of stem cells that are going to go in and fix up the damage that has been done. There is research going on into that area, and we heard at the conference from Natalie Payne, who works at Monash University, and she is looking at stem cells, and she's been working in mouse, in a mouse model of MS-like disease. And she can show that when you do transplant in particular types of immune cells, they don't actually integrate into the body. They don't engraft into the body, into the nervous system, but they seem to give out chemicals that help support the nervous system and help repair the nervous system. So I think there may be, down the track, the scope for stem cell transplants that will repair or help to encourage repair in the body. But I think that what we're going to find is that what we find out about stem cell research is it's going to give us clues about drugs or other mechanisms that we can stimulate repair. It'll give us clues. And I think that there's still a lot to be resolved when it comes to stem cell research. But what was the really exciting thing at this conference was about finding out about the stem cells that exist in our own brains and spinal cords that repair our brains all the time, and finding out how we can actually get them to do their job better at repairing myelin in MS. Dr. Kayleen Young is from Tasmania, and she's a young, sort of early career researcher who is building up her own team and doing some amazing work. And as I said, there's a collection of researchers in Melbourne that are doing similar work, and they're looking at how does myelin grow in the first place? When we're growing as a child, all the nerves in our brain and spinal cord, they get coated in myelin. So that process that happens in development, how can we make that happen again, happen better after myelin has been damaged in disease? And these researchers are looking at the chemical signals that happen in the stem cells that exist in your own brain to say, well, what makes a stem cell in the brain decide when it's going to just sort of replicate and build new stem cells, or when it's going to actually stop dividing and actually turn into fresh new myelin. And we're getting some amazing clues from that about how we might be able to stimulate that to happen in MS. We know that there is something in the brain around the inflammatory lesions that actually inhibits myelin repair, but we know that myelin repair does happen in the MS brain. So with the clues that these researchers were coming up with about how to sort of switch off the inhibition, stop the block on repair, and encourage that actual repair process to happen. And these young researchers, they've over the next couple of years, will be making some great progress, I feel absolutely certain. So one of the other international speakers that came to our conference was Professor Luca Battistini from Rome in Italy, and he was talking to us about the role that the Epstein-Barr virus plays in MS. Now, I talked about the risk factors right at the beginning for MS, and we know that the EBV virus, which is involved in causing glandular fever, it's a very common virus. 90% of us in the room will have carry this virus in our bodies, and it doesn't really cause much of a problem. But we know that I think it's rare, or you will not find a person with MS who does not have signals of a prior EBV infection in their body. And so looking at the way that the virus interacts with the immune system, it actually hides and sits inside B cells. And we know that changes the way those B cells work. And and there's also something about people with MS in the way that their body deals with EBV-infected cells. It doesn't seem to be able to control and remove them in the same way that people who don't have MS do. So we need to be able to tease apart what's happening with that. And we're beginning to get a picture that some of the genetics of MS change the way the immune cells deal with EBV. And also aging and other factors such as smoking and maybe the way vitamin D changes the immune system might impact on the way that the body controls the virus. So Professor Battistini talked about his research internationally, and we also have a homegrown EBV expert, Professor Pender, who's also been looking at the way that the body, and he's shown that we have a particular type of immune cell that is in people with MS is actually not working properly, is not clearing away those infected cells. And we still need to understand a bit more about exactly why that leads to MS, but it's a really interesting step along the way. And Professor Pender is actually working with his colleague Rajiv Khanna in Queensland, and he has developed, because there are other diseases caused by EBV, and there are certain cancers that are caused by EBV, and he's been developing an immune cell therapy, so priming immune cells in the dish in the laboratory, and then infusing them back into the body so that they're primed to recognize a cell that's infected with EBV and clear it away more efficiently. And Professor Pender has treated one patient, one progressive patient with this therapy. There were no problems with safety, so he's moving on to a phase 1 trial, which is going to look in 10 people with either secondary progressive or primary progressive MS to see whether this treatment might be safe and might be showing any signal of improving the symptoms and halting the disease. So it's really, really early stages, and we have to wait patiently for the outcome of this phase 1 trial and see whether he's going to be able to move on to the next phase, which will be a larger trial to prove whether or not this therapy works and can slow down progression. We talked a lot about rehabilitation and physical activity, and also looking at some of the symptoms of MS that affect thinking and memory and information processing. And also the impact that MS can have on mood. So things like stress and anxiety and depression are very common symptoms in MS. I'm not going to talk about physiotherapy and rehabilitation because my colleague, Associate Professor McGinley, is going to talk to you about that later on. But there was some really interesting work happening in that area that was discussed at the conference. But I will mention two of the researchers were talking about supporting people with MS in relation to depressive and anxiety symptoms. And we know that there's actually a bit of a vicious cycle in that MS can, the disease process of MS can increase the risk of developing depression. But depression itself can also exacerbate some of the symptoms of MS. Depression has an impact on thinking and memory. And anxiety is also a very common result of MS, but it too can contribute to thinking and memory problems. So it's really, really important. These researchers were talking to us about how important it is that clinicians and allied health researchers and psychologists are able to work alongside patients with MS and work alongside the neurologists to address the psychological and psychosocial symptoms of MS, because we know that it can have not only an impact on quality of life, but it can have an impact on the disease process itself and the way the symptoms of MS are experienced. So there's great efforts being made to develop interventions. And Lisa Karopoulos, who's based in Melbourne, was talking about a cognitive behavioural therapy process to help with depression in MS. And Karen Ribbons, who's from Newcastle, was looking at the effect that anxiety has on memory and thinking skills in MS as well. So there are many, many different ways that people are looking at this research, and there are already services that exist to help deal with some of these symptoms of MS. So it's really important that we start working out how best to coordinate and collaborate so that the symptom management is evidence-based and is targeted in the best way to affect those symptoms and keep people as healthy as possible. I'm not going to talk too much about MS treatments, but because Professor Butt-Scriven is going to talk about that later. But at the conference, we heard a lot from researchers who are working on databases. There's a database that Professor Botskuven looks after called MSBase, which is an international clinical database. And it has the data of over 30,000 people with MS from all over the world. And it collects data on the treatments that they're taking and all of the relapses that they have and all of their MRIs. Everything is in there. And so it's a huge resource for almost doing clinical trials in the computer. You can look at all of these people and you can match them up by characteristics and pairs and look at what outcomes they have depending on what treatments they've been on and so on. And so there was a lot of young researchers that work with Professor Botskuven who have been looking in this database for information, and they've been able to show really interesting things about the duration of treatment. So staying on treatment for longer, yes, it actually does have an impact on the long-term outcomes. So we know from clinical trials that the medications for MS suppress relapses and can delay the development of progressive disease. But in real life, over the long course of MS, does it really make a difference to the long-term outcome? And there is a lot of data out there that says, well, perhaps it doesn't. And there's a lot of information out there that says, well, perhaps in the long term, things might be better initially, but in the long term, are they really any better? But what these researchers have been able to show is that over the long term, starting treatment early, staying on treatment longer, and some of the more high-strength therapies actually can have quite a significant impact. One of the researchers mentioned a change in relapse rate over a 1-year period that actually over 5 years would mean that you would reach a disability milestone much later. So it's really interesting to see that coming out, and it's really helpful. One of the neurologists in the audience stood up and said, this is really great. This means that I can go back to my practice and with our patients actually talk about what impact these treatments have and what the difference it's going to make in the long term, and help them to make really informed choices about the types of treatments that they use. So while clinical trials are absolutely vital for checking the safety and that treatments are working, monitoring the way those treatments work over long periods of time in real live patients who have not been selected for the clinical trial but have all the sort of comorbidities, all the diseases and other things, factors that go along with their lives, that it actually does make a difference. MS Research Australia became a member of this alliance in 2014. The alliance was established in 2011 by MS organisations all around the world working together with the MS International Federation. And these are all MS societies that have a big interest in research as well as providing care and services. And these societies have all got together and said the biggest unmet need in the MS community today is progressive MS. As you're probably fully aware, there are no treatments that have an impact on the progression of disease once you've got to secondary progressive or if you're diagnosed with primary progressive MS. All of those 11, 12 treatments that are available for relapsing remitting MS don't work. And so we need to actually focus the research community's mind on the problem of progressive MS. And we really need to focus attention on symptom management and rehabilitation that's going to make a difference to people who are already living with progressive forms of MS. So over the next few years, the Alliance is working on bringing researchers together, getting them to collaborate. Huge international collaborations are going to be funded, and in a really unique way, focusing everyone's mind on this problem. And I think that we'll see over the next couple of years some really interesting work coming out of this as a result of this alliance. And the really exciting thing is that it's got all the MS societies from all around the world working together and sharing information and expertise as well. So with all this attention on it, I think we can see some real movement over the next year or two. I am going to stop. I think I've forgotten to say a million things about the exciting stuff that happened at the conference, but I hope I've given you a sense of all the different areas of research that are going on, both in Australia and around the world. And I hope that even though I've zoomed over a lot of those areas, that you've got a little bit of a feel for why we work on certain areas of research and how we we can see, even though it may not make a difference tomorrow, that down the track we're putting all those ideas together, bringing the threads of what we know about MS together, and really putting that together into a direction where we can make something happen in terms of new treatments and new ways of managing this disease.